In 1943, the strategic landscape of World War II was shifting. The Ruhr Valley, a vital industrial heartland of Nazi Germany, held within its grasp the lifeblood of the enemy's war machine. The dams that harnessed the rivers for power were more than mere structures. They were formidable barriers, ensuring the smooth operation of factories and infrastructure critical to the German war effort. In essence, these dams were fortresses, and for the Allies, they presented a significant target. The Royal Air Force, faced with the urgent need to disrupt German operations, devised a daring plan dubbed Operation Chastise. This mission aimed not just to damage, but to destroy these essential dams, the Möhne, the Eder, and the Sorp, through an unprecedented method of aerial bombardment. The destruction of the dams would have far-reaching consequences, flooding factories, crippling supply lines, and demoralizing the enemy. The RAF understood that a conventional bombing approach would not suffice. They needed something revolutionary. Enter Barnes Wallis, an innovative engineer whose ideas were as unconventional as they were brilliant. Wallis proposed the design of a unique bomb that could literally bounce off the surface of water, allowing it to evade defenses and strike directly at the walls of the dams. This concept was rooted in physics. The bomb would hit the water, skip along its surface like a stone, and drop precisely where it was needed. A remarkable feat of engineering, it came to be known as the bouncing bomb. The design itself was a marvel, featuring a cylindrical shape that housed explosive charges. It was fitted with a stabilizing mechanism and designed to be dropped at a low altitude to ensure its bouncing trajectory. The idea was not just to drop the bomb, but to send it skimming like a stone across the water until it reached the dam, where it would detonate and cause catastrophic damage. To execute this bold plan, Wallis needed not just a brilliant invention, but also skilled airmen willing to risk their lives for this audacious strike. The mission would require precision flying, exceptional courage, and unwavering determination. Under the banner of 617 Squadron, dubbed the Dam Busters, these young men would become part of an extraordinary chapter in military history. As the operation approached, the stakes grew ever higher. The RAF was acutely aware of the challenges ahead. They would be flying low over enemy territory, facing anti-aircraft artillery and inclement weather. Yet this crew was bound by a common purpose and a shared sense of duty. Each airman understood that they were not just targeting a collection of concrete and steel, but striking at the very foundation of Nazi Germany's industrial might. This blend of ingenuity in engineering and extraordinary acts of bravery set the stage for an operation that would redefine aerial warfare. The bouncing bomb was not merely a tool, it was emblematic of how desperate times can spark extraordinary solutions, illuminating the creativity and spirit that thrives even in the darkest of moments. As we delve deeper into this story, we will explore not just the technical achievements but the personal narratives of the men who bravely flew into the jaws of danger, armed with a weapon crafted from sheer audacity and innovation. The road to the development of the bouncing bomb was fraught with engineering challenges that required unyielding determination and creativity from Barnes Wallis and his team. The concept itself was revolutionary. Create a bomb that could skip across the surface of water, bypassing anti-aircraft defenses, and strike the dam with pinpoint accuracy. To achieve this, Wallis faced the daunting task of not only designing a bomb that could bounce, but also ensuring it had the right specifications to make it effective upon impact. Central to the bomb's design was its unique shape. Wallis envisioned a cylindrical bomb with a rounded front, ensuring that it would skip off the water's surface instead of sinking immediately. The key was in the mechanics of its deployment. The bomb was engineered to be dropped at a precise altitude and speed. Wallis determined that the ideal release point would be around 60 feet above the water, allowing it to skip across the surface before sinking close to the dam. To facilitate this, he introduced a specialized tail and a tailored fuse that would detonate only upon impact after the bomb had settled beneath the surface, allowing for a more powerful explosion against the dam wall. However, achieving the right trajectory and bounce required rigorous calculations and tests. Wallis and his team employed various unconventional methods to validate their theories. Using a nearby lake, they conducted trial launches with scaled-down models of the bomb. These tests involved careful adjustments to parameters like angle, height, and speed. Engineers would adjust the bomb's weight and surface texture, experimenting with different designs to find the perfect balance for an effective bounce. The testing phase culminated at a facility known as the bombing range. Here, Wallis and his team faced a crucial breakthrough when they determined that the bomb needed to maintain a specific spin to create enough rotational lift for the bounce effect. When the tests demonstrated promising results, Wallis knew they were on the brink of success. As the trials progressed, the designs evolved, iterating on feedback from each test run until they had a prototype that met their objectives. In one pivotal trial, the bomb was dropped from a plane at the planned altitude. With the heartbeats of the engineers echoing in their minds, they watched as the bomb skimmed across the water, bouncing effortlessly before plunging into the depths. All eyes were on the device as it exploded against a concrete wall, mimicking the conditions it would face during the actual raid. Cheers erupted as the power of the blast confirmed that this audacious concept might actually work. This dedication and innovation culminated in what would become known as the upkeep bomb. This striking combination of physics and creativity not only showcased Wallis's engineering genius, but encapsulated the spirit of his team, resilient, imaginative, and driven by a sense of urgency against the clock. As they approached the final designs, uncertainty still loomed. They knew that the true test of their creation would come not just in trials, but when the brave men of 617 Squadron took to the skies on that fateful night in May 1943. The stage was set for a mission that would not only challenge conventional warfare, but would also etch their names into history, where engineering marvels united with the courage of young airmen willing to defy the odds. As the dawn of the operation approached, the crews of the Royal Air Force's 600 Squadron prepared themselves rigorously for one of the most audacious raids in history. The training for Operation Chastise was intense, as the airmen grappled with the complexities of flying at traditionally dangerous altitudes, and all while navigating the unique demands of the bouncing bomb. They undertook several practice runs and simulations, honing their skills to drop the upkeep bomb at exactly the right height and speed. In the days leading up to the mission, the gravity of their task weighed heavily upon them. Each pilot understood that their success hinged not just on their flying skills, but also on the careful synchronization with their bombardiers, who would need to execute their roles with clockwork precision. On the night of May 16, 1943, the stage was set. The aircrews gathered one last time, their hearts pounding with both fear and excitement. The weather had turned favorable, clear skies illuminated by a waxing moon. 9 Avro Lancaster bombers, named after famous dams and each carrying the crucial bouncing bombs, took to the skies in a carefully orchestrated sequence. Their mission was not only to breach the formidable Möhne and Eder dams, but also to strike a blow at the heart of Germany's war infrastructure, thus crippled industrial production capabilities. As they navigated the flight path, the airmen directed all their energy toward visualizing the targets ahead. The dams stood like looming giants in the darkness. After a lengthy journey across the countryside, they approached their first target. But no plan, no matter how well executed, can anticipate every challenge. Almost immediately, the crews encountered fierce anti-aircraft fire. The gunners at the dams were well prepared for an aerial assault, and the night sky erupted in the flashes of flak and tracer rounds. Pilots had been extensively trained for low flying, but now they had to push their limits further than they had ever anticipated. Flying at perilous heights, they dodged the bursts of gunfire, the sound of metal ricocheting off their aircraft punctuating the tense air. Inside the cockpits, young men under the weight of their responsibility struggled to keep their hands steady on the controls. Each second became a battle against fear and self-doubt, a test not just of skill but also resolve. The closer they edged toward their targets, the more intense the barrage became, challenging their focus. Then came the moment of truth. Upon reaching the drop zones, those fateful seconds before release became an eternity. Everything they had trained for, every ounce of ingenuity crafted by engineers like Barnes Wallis, culminated in this pivotal instant. One by one, the crews began their runs. Precision was paramount. Missing the target could mean failing the mission and losing lives. Each bomb launched with the hope of bouncing off the water's surface, skipping towards the reinforced barriers of the dams. As the first bombs hit the water, time seemed to slow. Would they skip? Would they strike true? Every eye was trained on the horizon, where history would soon be written in the dark waters of the Ruhr Valley. The stakes were higher than the crew's flights, for each successful impact signaled not only the triumph of engineering genius, but the courageous spirit of young airmen determined to alter the course of the war. The successful strikes on the Möhne and Eder dams had immediate and profound effects, not just for the German war effort, but for the Allied forces as a whole. The destruction unleashed torrents of water that swept through the Ruhr Valley, flooding factories, infrastructure, and transportation networks crucial to the German military machinery. This disruption hindered the production of munitions and delayed significant military operations. It was a strategic blow that echoed across the battlefield, showcasing how a single well-executed raid could alter the course of war. Yet this audacious operation came at a steep price. Of the 133 airmen who participated in the raid, 53 lost their lives during the mission. These brave young men, many barely out of their teens, showed unparalleled courage as they faced enemy anti-aircraft fire and the very real threat of being shot down or captured. Their commitment to a cause greater than themselves resonates through history. Each flight crew knew the stakes. They were not just targeting concrete structures, but the very fabric of the enemy's war capability. The bravery demonstrated during Operation Chastise embodied the spirit of the Royal Air Force, and many who participated were nothing short of heroes. Remarkably, the legacy of the bouncing bombs transcends the immediate tactical victories of the Dambusters raid. The engineering ingenuity that went into the design of the upkeep bomb continues to influence military engineering and tactics to this day. The concept of precision bombing using specialized munitions emerged as a key element in aerial warfare, guiding future generations of engineers and tacticians. Innovative designs that emerged from this operation paved the way for more advanced weaponry and bomb delivery systems, demonstrating the importance of creativity in overcoming seemingly insurmountable challenges. Moreover, the Dambusters raid inspired subsequent missions that relied on similar precision bombing techniques, marrying engineering innovation with bold military strategy. The principles established by Barnes Wallis and his team of engineers transformed how air power was perceived and utilized in warfare, proving that sometimes audacity can yield remarkable results. Today, the legacy of Operation Chastise serves not only as a testament to technical innovation, but also to the indomitable human spirit and the willingness to risk everything in the face of daunting odds. The stories of the aircrew and their families remind us that behind every military operation lies the weight of personal sacrifice and the fragile nature of life during war. As we reflect on this remarkable chapter in history, we are reminded that the ingenuity of engineering can indeed create extraordinary solutions in desperate circumstances. The bouncing bomb, a creation born out of necessity, changed the landscape of aerial warfare and left an imprint on military strategy that persists today. It stands as a powerful symbol of what can be achieved when brilliant minds collaborate and when brave hearts are willing to lead the charge against tyranny.